Welcome to this talk about Windows App SDK with .NET from Tutorialr.com/talks. .NET is the free open-source cross-platform framework from Microsoft that enables developers to create powerful cloud services along with building modern applications for mobile, web, and desktop. .NET is updated each year with improvements or features, with even-numbered long-term releases supported for 3 years or odd-numbered standard-term releases supported for 18 months. .NET includes C#, which is also updated yearly, and is a modern, innovative, open-source programming language with type safety, language-integrated query, asynchronous programming, and more. .NET applications can be developed for any device or platform, including iOS, Android, Windows, Linux, or macOS, with world-class developer tools including Visual Studio and Visual Studio Code. .NET Latest Software Development Kit, or SDK, which includes the latest version of C# along with documentation and information, can be found by visiting .NET. That's dot.net. Windows 11 is Microsoft's most powerful and easy-to-use release of the Windows operating system that helps you get things done with thousands of applications. Windows 11 is optimized for productivity, with features such as Snap Assist to organize your applications or play the latest games with reality rivaling graphics. Windows 11 is designed for performance and security, with multiple layers of protection to keep your information and your identity secure. Windows 11 is enhanced with Copilot, which is an AI feature that allows you to kickstart your creativity or help you as an intelligent assistant. Windows 11 information, features, functionality, latest hardware, and more can be found at windows.com. Widgets are small containers with text and graphics that can be a companion to a Windows application, providing frictionless access to most needed information. Widgets help you save time and stay organized by quickly accessing information at a glance without the need to open an application window or website. Widgets can be customized or personalized depending on the widget, such as your location for a weather widget or what size of widget to display. Widgets can be developed using adaptive cards provided from a progressive web application or from a Windows App SDK application. Widget documentation, including how developers can implement a widget provider, can be found at aka.ms/widgetdevdocs. Pomodoro technique is a time management technique developed by Francesco Cirello in the late 1980s using a timer shaped like a tomato, or pomodoro in Italian. First thing you need to do is decide on a task that you need to get done. Then you set a timer for a period of time, which is usually around 25 minutes. Once the timer is finished, then you take a short 5 to 10 minute break from the task with this work break cycle known as a pomodoro. Once the short break is over, you set the timer for 25 minutes to begin a pomodoro and repeat the pomodoro cycle 4 times. After 4 pomodoro work break cycles, you take a long 20 to 30 minute break and start again until your task is completed. What is Windows App SDK? Windows App SDK provides a unified set of APIs and tools to create native Windows desktop apps targeting from Windows 10 RS5, the latest version of Windows 11. Windows App SDK is not tied to updates to Windows, but instead delivered via Microsoft.Windows App SDK from NuGet, which is updated at least every 6 months. Windows App SDK supports both the modern WinRT language-independent API delivery system, along with the native C-based Windows APIs. Install Windows Application Development Workload for Visual Studio to build WinUI 3 in desktop applications for Windows using C# and XAML. You can find source code and how to get started with Windows App SDK at github.com/Microsoft/Windows App SDK. XAML, or Extensible Application Markup Language, is an XML-based declarative markup language that can define user interface controls that can support rotation, animation, or other effects. Developers can decouple the implementation of an application, including any events, business object, and other code in C# from the design and user interface of an application in XAML. Developers can use data binding from source values to target properties, including converting values to present data to users or allow interaction with data from users in XAML. Applications can scale as needed, thanks to vector-based controls, along with lines, shapes, and vector images. They can also support a variety of brushes in XAML. Developers can completely customize the look and feel of an application without impacting the implementation of an application with XAML. WinUI is the modern user interface framework for building intuitive and accessible native Windows applications using the latest user interface patterns. WinUI 3 is shipped as part of Windows App SDK and decoupled from Windows itself, enabling new features to work on older versions of Windows. WinUI 3 also provides the native user interface platform on Windows, cross-platform frameworks such as .NET MAUI and UNO platform. WinUI 3 implements modern controls that feature the latest Fluent design system from Microsoft, used in Windows itself. You can find more, including source code for the latest release of WinUI 3 at github.com/Microsoft/UI-XAML. Fluent Design System with Fluent 2 are a set of guidelines from Microsoft for design and interaction that are used by modern native Windows applications on Windows 11. Fluent 2 includes design principles for intuitive and expected experiences in Windows applications, including color, iconography, motion, typography, and more. Developers can build great experiences with WinUI using components such as button, checkbox, combo box, and text box incorporating Fluent design. Developers building apps with WinUI 3 using components helps ensure an accessible foundation for diverse and delightful experiences for everyone. You can find out more about Fluent 2, which is the latest version of Microsoft's Fluent design system at fluent2.microsoft.design. Let's look at a demo of using Windows App SDK with .NET to create a Pomodoro application that also features a widget in Windows 11. Okay, here we have our Pomodoro application. We have 3 different timers. We have the timer for the task itself, which is set to 25 minutes. We have a timer for the short break, which is set to 5 minutes. And we've got a timer for the long break, which is set for 20 minutes. Let's go to the short break. We'll pretend we've done a task already, and we'll start the timer. This timer will count down, and during this break, we can do anything we want. But what we can also see is we have a widget, and this widget also shows what the current timer is doing. That's counting down. So watch it count down. Okay, so we've counted down for about a minute there. And we can see the timer is still going down on screen. And then we'll wait for the timer to complete. Okay, so our timer is about to complete, and that will be our break over. So let's wait to see what happens. And as you can see, the break has completed, and we got a message on screen saying that the break has been completed. And that's our Pomodoro timer. Okay, let's switch to Visual Studio. Okay, so here we are in Visual Studio. We have 2 projects in our solution. We have a desktop project and a library project. Let's take a look at the library project first. Here we have an alert object. This represents when the timer is completed. And here we have a Pomodoro item, which represents the timer that's displayed on the user interface, including the upper and lower colors displayed. And here we have an enum for our Pomodoro type, which can be for the task itself, which is our task timer, along with a short break and long break. Here we have an object that represents our timer itself, and we have different events, including when a timer has been added, removed, triggered, or updated. We can also scroll down and see some methods, including a tick method, which basically updates the user interface every time the timer ticks. And the start method will set up our timer, and the stop method will stop our timer. And here we have a constructor which will set up our object as needed. Okay, that was our library project. Let's take a look at the desktop application project. And here we are in the app.xaml. Our application actually has two user interfaces. One is the one you actually see, which is the one with the upper and lower portions and the timers. And the other is a headless mode used by the widget. We can see here that we're registering a widget provider, and that widget provider will effectively launch our application in headless mode, allowing us to interact with the actual widget itself. We also have some methods here to set up the application as needed when it is loaded. Here we are in our main window code, and this is where we basically set up our application. This is where we register our widget. This is where we interact with our widget, along with creating our toast notification that you see, and also any other events to make sure the user interface is updated accordingly, or anything else we need in the user interface. We also have a method when the actual application is loaded, so we can set up everything as needed. And we can take a look at the actual user interface itself. Here you can see the XAML that represents our user interface. As you can see, it's quite simple. We use data binding for the upper and lower portions, as well as the image that's used for each timer. We also have some converters to convert values that we need, including the images and the colors. We use the system.drawing in our library, so we need to convert that to the Windows UI color. So we use this converter. And to display the relevant images, we use this converter. And this uses the images that we have in our project. And this is the images we have. This not only includes the default images that we have for an application, but it also includes the different resources that we need to display the different sizes of image that we see in the toast notification, as well as the application itself. Okay, so let's take a look at our widget provider. This code is some standard code from Microsoft setting up a widget. We have some methods to recover any existing widgets to make sure that we set them up correctly, or remove any widgets that are no longer needed. And we also can create a widget as well to make sure that it's registered correctly when our application is updated, as well as setting up any events and various other things that we need to make sure the widget updates correctly. We have some different classes in here that also come from Microsoft to basically interact with a widget. We have our registration manager that will register our widget for use when in headless mode. So that's when the widget is actually updating. And we can also register our widget when the application is running normally, and we can interact with that widget. The actual widget itself is defined with a template. We can open that template here. And this is using the adaptive card syntax, where you basically define it as such. Any images have to be URLs, so we're just using the Fluent UI emoji images directly from Microsoft's GitHub repository, basically show those in the widget itself. And we're basically just using the timer clock here, but you could have more complex widgets. We also have two sizes supported potentially, with a smaller size or a medium size, but there's also a large size as well. And you can define different kinds of layouts for adaptive cards as needed. And that's our Pomodoro application. .NET is the free open-source cross-platform framework from Microsoft that enables developers to build modern applications for any device or for any platform, such as desktop. Windows 11 is Microsoft's most powerful, easy-to-use version of Windows, supporting widgets with information at a glance that can help you save time and stay organized. Windows App SDK to create WinUI 3 in desktop applications in C# and XAML, with Windows Application Development Workload supporting Windows 10 RS5 to Windows 11. Windows App SDK applications leverage WinUI 3, which is the modern user experience framework decoupled from Windows using the latest user interface patterns. Developers can create accessible apps using WinUI 3 components such as button, checkbox, combo box, and text box that incorporate the Fluent design system. Thanks for taking the time to listen to this talk about Windows App SDK with .NET from Tutorialr.com/talks. Here you can find links to the resources used in this talk.